In this presentation, I would like to talk about specific type of chromatography, focusing on ion exchange or ion chromatography, which is based on attraction of ions of opposite charges. More specifically, if you have stationary phase with positive charge, that analyte with negative charge will be attracted by different forces, by different strengths of their charge. And then mobile phase, which will have also negative charge, will compete over those sides and will elute the analytes. Thus, in ion exchange chromatography, we are studying ions or polar molecules which are exhibiting charge. Ion exchange mechanism involves exchange of the specific ion, anion, or cations. So we have usually one type of analysis at a time. Ion exchange chromatography is using this mechanism where we have stationary phase with a specific charge on which the analytes of opposite charge can be retained. Ion chromatography implements ion exchange chromatography mechanism, but it has specific kind of detection, electrolytic detection, typically based on the conductivity. Stationary phases in ion chromatography can be either cation exchangers or anion exchangers. Cation exchangers have negatively charged groups. They can be strong or weak depending on their attractive forces. The strong can be sulfonic base, weak can be carboxylic based. For anion exchangers, so if the analyte is anion, we can use tertiary or secondary amines. Mobile phase in ion chromatography has to be selected so it can elute the target analytes from the stationary phase. In this case, we have carboxylic acids or carboxylic acid functionality as a stationary phase, and we are having as the analytes different types of amines. Our mobile phase will be methane sulfonic acid, which has a proton which has stronger affinity to the carboxylic group and therefore displaces the amines from the columns. Now, what is important about mobile phase is also it has to be compatible with detection mode. So, in the case of conductivity, if it's highly conductive, we might have to suppress it. We will be talking about suppression a little bit later. We have to look what is suitable concentration of the competing ion, of that proton. If it's too high, we might have too high conductivity and interference with the detection. If it's too low, we might not be able to elute the target analytes. We also have to look at a pH and buffering capacity. In this case, we want to have the amines to have charge. Therefore, we have to look at their pKa and work 2 units lower than its pKa. There are additional considerations for mobile phases. Mobile phases may use some complexation agent, and they also can use additional organic modifiers. Now, how does the separation work? If we have analyte which have A plus and B plus cations, and we have again stationary phase which is carboxylates, and mobile phase with methane sulfonic acid. In this case, we can imagine we have lithium, sodium, where one of them will be stronger. In typical cation exchange chromatography, sodium will be stronger because it has smaller hydrated radius. Therefore, it will be more strongly retained, and lithium will elute earlier, will have shorter retention time, and then sodium, as they will be displaced by the proton from methane sulfonic acid or reagent C. Specific case of the separation for anion exchange is shown on this chromatogram. We can see important factors which affect separation. As mentioned before, smaller hydrated radius is very important, and species with smaller hydrated radius are more attractive and stay longer, have longer retention times. So if we compare fluoride, chloride, bromide, and iodide, iodide gets most retained because it has smaller hydrated radius. If we have higher charge, if we compare nitrate and sulfate, nitrate, and sulfate, we see that higher charge also is more strongly attracted. Finally, if we look at the sulfate and thiosulfate, we see again that attraction forces for steric compounds are stronger. So we have here higher polarizability. Mentioned before suppression. Suppression is a very important element when we are doing conductivity detection. It reduces conductivity of the mobile phase. If we have highly conductive species in mobile phase, we have lower sensitivity. Therefore, if we remove these species from the mobile phase, we can minimize the baseline and increase sensitivity. There are different types of suppressors. There can be electrolytical and chemical, which are membrane-based. Usually you have the flow from the column coming through the membrane system, and on each side are membranes which are allowing for passage of unwanted ions. Another way is to use column suppressor with ion exchange. Typically, ion exchanger of opposite charge than the column is used. In this setup, you see that there are actually 3 ion exchangers. Ion exchangers has to be regenerated over the time. And so once one is used, the other 2 are being regenerated. And then they are switched and another ones are being used. Exact principle how the suppression works. Here we have again anion separation, fluoride, chloride, sulfate. It's separated on an ion exchanger. The mobile phase, in this case, is potassium hydroxide. We need something with very strong ions, so hydroxide ions, to displace fluoride, chloride, and sulfate from the stationary phase. However, because of this mobile phase, we are having elution of salts from the column. These salts, potassium, creates very high conductivity and as well as potassium hydroxide. So what can we do? We can replace the potassium with hydrogen, basically making the solution aqueous solution. Now we are eluting acids in the water. What happens is the detector. If we don't have suppression, that potassium hydroxide creates very high signal, and so we practically don't see our species which we are analyzing. However, if we remove potassium hydroxide, now we can see very nicely our target analyte. So we are improving sensitivity. Finally, how overall ion chromatographic system works. We start with the mobile phase. In this case, you can use actually eluent generators. So instead of making the mobile phase dissolving potassium hydroxide or sulfuric or methane sulfonic acid, you can actually use pure water and you use solid reagent and we can generate it electrolytically. Then you inject the sample as you're familiar with HPLC with 6-wave valve. The next step is going through ion exchange separation. So for anions, we need anion exchanger. For cations, cation exchanger. Note, we always use guard columns to protect our column from sample contamination. From the analytical column, we go typically to the suppressor device. Suppressor device is removing species of opposite charge, reducing the conductivity of the mobile phase. So then we can measure conductivity only of our analytes. I would close that other detectors can be used with ion chromatography. Nowadays, fluorescence, UV, or mass spectrometers are used. Still, conductivity is one of the methods of choice because of the cost and simplicity.